Hello students, our next topic is shell model. Here we explain the magic numbers in the nucleus. So in our last model, which was the liquid drop model, we assumed that each nucleon interacts only with its nearest neighbors. Right? Here we assume the extreme case, which is each nucleon interacts with a general force field produced by all other nucleons, which is similar to the case of fermions. That is electron. Electrons are fermions and nucleons are also fermions. That is neutrons and protons are also fermions. Okay, according to this model, since the nucleus are also fermions, several nuclear properties vary periodically with Z and N, atomic number Z and N, in a manner reminiscent of the periodic variation of atomic properties with Z. We know that the outermost configuration or the atomic number divides the atomic properties. Atomic number defines the various atomic properties of an atom. Right? Similarly, Z and N could account for the nuclear properties also, since like electrons, nucleus are also fermions. So we know that in the case of an atom, the outermost electron numbers with atoms with total atomic number 2, 10, 18, 36, etc. are exceptionally stable because these are the fully filled levels. So they interact less. So there is no interaction between them and they are highly stable. Such a kind of effect is observed with respect to nuclei also. Okay, that is nuclei that have 2, 8, 20, 28, 50, 82 and 126 neutrons or protons. These numbers of neutrons and protons are more abundant than any other nuclei of the similar mass number, suggesting that their structures are more stable. Okay, so nuclei with these many number of neutrons or protons, okay, they are highly stable. So we could explain by the help of this shell model these why such numbers are highly stable. Okay, these numbers 2, 8, 20, 28, etc. These numbers are known as magic numbers in the nucleus. Now, the shell model of the nucleus is an attempt to account for the existence of magic numbers and certain other nuclear properties in terms of nucleon behavior in a common force field. So, in the case of shell model, we are taking into account of the existence of magic numbers. We are trying to explain the magic numbers and also some nuclear properties which account for the fact that nucleons behave in a common force field similar to electron. Okay. Now, how magic numbers arise? This problem was finally solved independently by these two people, Maria Goeppert Mayer and J.D. Jensen in 1949. So they realized that it is necessary to incorporate spin-orbit interaction. So they incorporated spin-orbit interaction whose magnitude is such that the consequent splitting of energy levels into sublevels is many times larger than the analogous splitting of atomic energy levels. Okay, we know that atomic energy levels split due to the effect of spin orbit interaction, right? Similarly, there is an interaction between spin and orbit and hence there is a splitting of atomic energy levels. This spin orbit interaction was incorporated into the theory of a nuclear structure. So the exact form of the potential energy function then turns out and not to be critical, provided that it more or less resembles a square wave. So up to some distance there is a high field and after that it has no field, which is approximately the nuclear force. Now we know that the shell theory incorporated the spin orbit interaction. It assumes that LS coupling, L, what is L, which is the orbital angular momentum, S is the spin angular momentum. LS coupling holds only for the very lightest nuclei. How is this coupling? In which L values are necessarily small in their normal configuration. So in this scheme, the intrinsic spin angular momentum SI of the particles, individual spin angular momentum concerned the neutrons from one group and protons another. Okay, independently have different SIs are coupled together into a total spin angular momentum S. So the individual spin of the nuclei combine together to form S. The total spin momentum and the orbital angular momentum Li. These are the individual orbital angular momentum are separately coupled together into the total orbital angular momentum L. Then this S and L are coupled to form the total angular momentum J, which has a magnitude root of J into J plus 1 H cross. After a transition stage in which an intermediate coupling scheme holds, the heavier nuclei exhibit JJ coupling. So this holds for majority of the nucleus, which is the JJ coupling. In this case, the Si and Li of each particle are first coupled to form a Ji for that particle of magnitude root of J into J plus 1 H cross, and the various Ji then coupled together to form the total angular momentum J. This is JJ coupling. So this JJ coupling scheme holds for the greater majority of nuclei. Majority of nuclei is in this coupling scheme, JJ coupling scheme. Now this is our explanation of magic numbers. Here you can see the magic numbers 2, 8, 20, 28, 50, 82 and 26, 184. So our first level is 1s, second 2p, 3d, 2s, etc. These are the levels without spin orbit coupling. So without coupling, these levels are not at all splitted. Okay, and with spin orbit coupling, there is a splitting and the levels are designated here, and you can see the levels, splitted levels here. Okay, now let first take on the first level, 1s. 1s is 1s half. That is, J is equal to half. Since L is 0, you know the values of S, P, D, F, etc. S0, P1, D2, F3, etc. So what is the spin orbit interaction or S plus L? So S is half. Half is the spin value for the nucleon. Half plus 0. So it is half. So 1 is half. This is the unsplitted level. In this level, the nucleons per level can be 2J plus 1. That is, it can accommodate 2 electrons. So, the nucleons per shell is 2. So, in this shell, there are 2 nucleons. So, the total number of nucleons is 2. Okay. Take the next level, 2p. P has a L value 1. So 1 plus half, it is 3 by 2. 3 by 2 can take values from minus J to plus J. So that is 3 by 2 and half. Okay. So in the 3p 3 by 2 levels, it can accommodate 4 electrons, and in 2p half it can accommodate 2 electrons. So the nucleons per shell, in this shell there are 6 nucleons. Okay. Now the next shell is a combination of 3D and 2s. 3D is split into 2. 3D 3 by 2 and 3D 5 by 2, and 2s is unsplitted. So since s equal to 0 value, so 0 plus half, it is single value half. Okay, the j value is also half. So here you can see here 6, here 2 and here 4 nucleons. So the nucleons per shell is 12. Okay. Similarly, we have 4f, 7 by 2. It has 8 electrons. The nucleons per shell is 8, and it goes on like this. Okay. Now we take the total nucleons up to that shell. First shell has 2 nucleons. The second, up to second shell there are 8 nucleons. Up to third shell there are 20, then 28, 50. So these are the filled levels. These are the filled nuclear shells. So this spin orbit interaction account for the explanation of magic numbers. Okay.